Hello everyone, in this tutorial video we'll simply install LAMMPS. So LAMMPS is basically the software for molecular dynamics and it's a open source software. So downloading the LAMMPS, we should write LAMMPS download, and from here we'll go to download LAMMPS, then install pre-built Windows packages. Okay, then we'll simply click http packages lamps.org here, and from here we'll simply click the latest versions. So from here we'll just install the latest version, basically this lamps 64-bit latest.exe. So I have already you just need to click here. So if you click here it will start downloading. So I do not need to download again as I have downloaded already. So this is for running your code, this software, the lamps. So for visualizing your code running code, you just need to OVITO. So this is basically open visualization tool, OVITO. Okay, this is basically OVITO, the open visualization tool. Okay, so for this you just need to click on OVITO, download, then Windows, you just need to click here OVITO basics. So you will certainly see the OVITO basic has been downloaded. So I already downloaded the OVITO basic version and it's very easy to install. You just need to click run as administrator from here, and after that you just need to simply click next, and then close. It's like installing any typical software. Okay, so I am not installing it now as I have already installed the OVITO. You can see the interface. So we'll see our visualization, our molecular dynamic simulation OVITO, and we'll run our code using LAMMPS. So this is actually for visualization. Okay, so please note that we are not running the code in OVITO, we are running the code in LAMMPS, and we are visualizing the simulation, the things in OVITO. So basically we are here we are running the nanoscale simulation, basically molecular dynamics. So for nanoscale, so you just need to remember we are simulating atoms. So atoms maintain distance, so you know, interatomic distance. So basically in solids the distance are very closer, so they maintain attractive force, and liquid maintains some distance, and gas molecules moves randomly. So you just you maybe not maybe in your class 9 10 and even in college you read about interatomic distance curve. Okay, so for interatomic distance curve you have seen something like this. Yes, something like this. Yes, this is basically the total energy curve, and you have also seen what this attractive repulsive force curve. So the here basically there is a force curve and there is an energy curve. Okay, so the interatomic energy, this energy comes as basically as a function of interatomic distance. So okay, so you just need to learn these things for simulating LAMMPS, and you obviously you just need to choose domain what you are simulating, whether you are simulating material properties, phase change modeling, flow simulation, or your domain actually what you are working with. And you can see from Google we can model protein, DNA, everything, every molecule in LAMMPS. Okay, so you can simply search on Google for that. So for now we are installing the LAMMPS, and we'll simply click run at administrator from here. Okay, so we are clicking on agree, install. So yeah, this will be certainly installed. Okay, so let's install this. Yes, let's install this. So yeah, our LAMMPS is being installed, and this will not come as a typical interface. Okay, you can not simply search LAMMPS, or it will come as an application. So you just need to call it. It won't come as an application. You just need to call it using your CMD. Okay, so you just need to, yeah, the installation has done. Okay, I simply click on the close. So for calling the LAMMPS, you just need to click what? Click Windows button plus R. Okay, so yes, I am pressing actually you just need to press Windows button plus R. I am just pressing Windows button plus R. Yes. Now here I just need to write CMD. Okay. So from here, uh, we will simply run the LAMMPS code. Okay, and visualize that. So yeah, as I have installed a LAMMPS, some files, examples, manuals, benchmark, etc. has been recently added in my uh, file hook. So I will simply go to there in this location, and yes, I will simply choose the example which I want to run. So the crack simulation is a basic one. So let's try with crack simulation. So we just need to open the code in open notepad. So this is basically LMP file. LMP means lamps file, and this may be the potential file. Okay, the maybe, I'm not sure, this may be the potential file. So basically we potential file, some potential files are already given in this example, and some you will find from GitHub or any university website or any paper. From any paper you can find the codes basically. So potential files are important for their in the potential file. There are mainly there have many parameters to model your atoms or molecule of specific components. So you need potential file to run lamps, and it's not that much easy. I am showing you. It's tough because you need to understand physics, actually the physics of atoms from here. So yes, this is my code for crack simulation, and here in these 4 lines or 5 lines you can see there is dump syntax. So to view our simulation from this default code file, we just need to remove this hashtag from this first dump syntax. Okay, this is basically the time step mostly. So we'll simply save it. Okay, we'll simply save it, and now we'll run the lamps code. So yeah, our code is where? Our code is in the C drive. Okay, our code is in the C drive, app data, in the app data. So simply I'll select C drive, I'll type C and colon, and from here where we just need to define where our code is. So for this definition or define, we'll simply type cd and we'll give a quotation mark, and we'll simply copy our file path. Okay, this file path, and we'll simply place it here and quotation mark close and here. And after this you have to write a general syntax or writing. This is lmp.in. For every type of file you always need to write this lmp in, and after that you just need to add file name. So here our file name is what? in.crack.lmp. So let's type it, in.crack.lmp, and if I press enter it will certainly run. Okay, so let's enter. Yes, it's running, and a dump file has been created here. Yes, this run completed, and we'll simply use OVITO, and we can simply open the dump file from using load file, or we can simply drag and drop here. So let's drag and drop this, drag and drop this here. So yes, this. Okay, we have simulated the crack file, crack simulation. Yes, our code is working. So yes, it's successful. So basically it's installation and the code run is very easy, but the physics is not easy if you do not understand what is happening actually, what you are writing on the codes. So yeah, I have another file here where I just added I just wrote a monocomponent order code. Okay, monocomponent order code I just wrote here from here. So I will not show you, I will not explain you the code right now. Rather than I will simply run again means for the first time you saw that I have maintained my C drive. So you can maintain your any drive. You just need to simply create a a specific folder in your specific drive. So I am choosing my F drive, and here I have created a lamps folder, and these are my simulations cases which I will run. So I am choosing case 1, and suppose I want to run case 1. Okay, so for this I just need to again similarly call the F drive firstly. So for this we'll simply write F. From here we'll simply choose the path where our code is, where I'll simulate. Okay, basically, so for this we'll simply click cd and quotation mark, and after that we'll simply put our path. Okay, so yes, file location path and quotation mark close, and we'll simply press enter. So now we just need to write the general syntax LMP in, and after that we just need to write the file name. So where is the file name? The file is basically this in mw so this is basically in text syntax. This is basically .txt file, and our again our if we see the example run not run as administrator, open file location. If we see the examples of crack simulation, there are basically there is many types of example. You can try the examples. I am basically tried the simplest one, the crack. So you can simply try the diffuse, dipole, then elastic. So that's not an issue. So basically the coded file was before was in LMP file, LAMMPS file format. Okay, so for this I have written in the previous file name as in.crack.lmp. But for now, what? For now, our syntax file save is in .txt format. Okay, for now, so we'll simply the file name as in dot our file name mw underscore evap. So our file syntax is what? Before the syntax was in LMP, lamp format file. So now our format is .txt. So we'll simply write it and simply enter, and it will certainly start to run. So this is very much simple actually. I have already run the simulation actually. Okay, so for this I want to see you the view the result. So you can simply drag and drop it here, and you can simply see the simulation. So I am not explaining the code here in this tutorial. Basically this was an basic installation tutorial and basic introduction to LAMMPS. So yeah, that's all for today everyone. So goodbye and thank you. Thank you.